Ah, hello, everybody. So my name is James. I am a business developer with Atmos UAV, and welcome to this Atmos webinar. And we're going to do a deep dive into an online demo with the Marlyn Cobalt drone. Thank you very much for joining us today from wherever you are in the world. So today we are, as I mentioned, going to be looking at the Marlyn Cobalt in flight. As you probably know, we're going to be doing it through Zoom. What I want to do is just point out real quick down the bottom of your screen. There is a Q&A button down there. If at any time you want to ask a question, feel free to type that in there at any time during the presentation, and at the end, I will try to get to as much as possible. But what we're going to be doing is having a look at the Marlyn Cobalt. So firstly, I want to share some of the results of the poll, which I shared with all of you when you registered for the webinar. And I think this is good just to go into, just to get a feel for who is joining us today. So I asked you first about your knowledge of Marlyn, and what you can see from this is that only roughly 1/3 of you know Marlyn in depth, and 2/3 of you are either seeing Marlyn for the first time or only have a little bit of knowledge. So for that reason, what I'll be doing is I will be covering a lot about the basics of Marlyn and really telling you why she has the features that she has and the benefits you get from it. But also that 1/3 of you who are experienced Marlyn users or may have seen a lot of it before or perhaps seen our previous webinars, I'll also be doing some in-depth stuff to keep you guys interested as well. Also, in terms of drone experience, you can see that only 1 in 6 people roughly have used a VTOL drone before. The rest of you are, in a small case, 1 in 5 using a belly landing fixed wing drone. But most of you, almost half, are using multi-rotor drones. And so for that reason, what I'll also be doing, what we also put into this webinar, is a little bit about some of the existing technology. So like multi-rotors and belly landing fixed wings, and even existing VTOLs, to show you the differences between what you're using and the Marlyn VTOL drone, and also the benefits that you get as a result. So what we are going to be covering today is firstly a little bit about who we are at Atmos. Secondly, the unique features of Marlyn and how they benefit you. Then we're going to dive straight into a Marlyn demo that we've recorded before. A little bit more information will follow that before rounding up with some Q&A. So firstly, a little bit about us at Atmos. So we are based in Holland. We're a little bit south of Schiphol Airport, for those of you that have been in the Netherlands before. And here at Atmos, we're passionate about 3 things. We're passionate about innovation, technology, and the environment. So for me personally, that's really great because I come from an engineering background, even though I work in business development. And I'm personally really passionate about innovation and technology. That's what brought me to Atmos. And also being from New Zealand, it makes me someone that's naturally quite passionate about the environment. So it's really cool to be part of a team that shares that as well. And what that means for you guys as users is that firstly, you get extremely innovative technology. It's what we focus on providing. And because we want to bring that technology out for you and want it to be workable in all environments, we make our drones capable of flying in the toughest weather conditions. So that's what our passion means for you guys as users. But where did the technology of our drone come from? Well, to start with, we're going to look at some of the existing technology out there that you guys have mentioned that you're already using. So the problem with multi-rotors, I mean, they're fantastically easy to use. They generate great data. But the problem is that they spend most of their energy simply just keeping the unit in the air. And that means when you want to take on big areas, you need a lot of sets of batteries, or it just generally takes a lot of time. So people who are wanting to remedy that will often go to a fixed wing drone. And again, these are able to cover large areas. They're able to get really good data and they're super easy to use. But the issue is that when they come into land, they can be somewhat risky because they're coming in and essentially crash landing with every flight that they're doing. And so it's as a result of that that VTOL drones came about. So VTOL drones were able to take off and land like multi-rotor drones, while still covering large areas like fixed wing drones. But the drawback of current conventional VTOL drones is that in moderate to high winds, they're not very stable or just not allowed to fly. In fact, for pretty much every VTOL drone in the world, the warranty is going to be voided if you take off and land in wind speeds of more than 30 kph. And so it's as a result that we really came about with the benefits of Marlyn. So firstly, looking at multi-rotors. Because Marlyn is a VTOL drone, it's able to get that fixed wing area coverage. So approximately 100 to 150 hectares per flight is what you're able to cover. So that's 250 to 300 acres for those of you who are operating on the other side of the Atlantic. Also, Marlyn's a VTOL drone. So that means for the takeoff and landing, you're not doing a controlled crash every time you come in and land. With Marlyn, you can take off and land very easily within any 2 by 2 meter area, which we're going to show you in a little bit when we do our live demo as well. So firstly, you don't need to look for those big, massive runway areas. And secondly, you don't risk the expensive electronics of the drone every time you come into land. And then finally, with Marlyn, because we want our users to be able to operate in even the roughest weather conditions, Marlyn's capable of taking off, landing, and surveying in winds of up to 45 kph. So other drones will probably tell you that they have a 45 kph wind resistance, but they won't be able to do one of those things. They won't be able to take off, land, or survey in those kinds of wind conditions. And with Marlyn, you can do all three. I'm going to be sharing with you some data on that a little bit later on in the webinar, and you'll also get a chance to see all that in action with some moderate wind speeds when we also look into our live demo. So how does Marlyn transform your surveys in terms of the features on Marlyn? Well, firstly, the way that she's able to get those benefits that I just described is firstly because of quad rotor control. So some VTOL drones will have less than 4 rotors. Some will have less than 4 rotors that are operating in the helicopter mode. But with Marlyn, you've got all 4 rotors operating like a quadcopter in helicopter mode. And what that gives you as a user is complete control in all 6 degrees of freedom and a lot more stability. So even in those high winds, you're able to keep very stable with the Marlyn drone. The other reason that we're able to be so stable and fly at such high wind conditions is because of the tail sitter design. So you may have seen there's different kinds of VTOL drones. There are tail sitters who take off on their back and then transition the entire body into airplane mode. And there are what's called wing plane drones. And they essentially will always be in the same orientation, but they will tilt their motors whenever they take off or land. What the tail sitter design allows you to do is fly at much higher wind conditions, because if you get wind gusts from different directions, it's not difficult for the drone to deal with those. And also it means there's less moving parts, less complexity, essentially less things that can go wrong. A common thing with wing plane drones is if they do catch a gust of wind underneath one of the wings, it's very easy for those drones to flip over, and that's a very expensive mistake. And finally, the last feature which really gives you the benefits of Marlyn is the rotating wingtips. So the portion of the wing at the very end, where you can see there's a small slit there, is actually rotating. And what that allows you to do is to have very fine control of the drone whilst it's in its helicopter mode. And also in high winds, it allows the drone to essentially lean into the wind while still keeping the thrust vector pointed vertical. And it's with those things that you can get these 3 things here, which you can get the full benefits of Marlyn, especially that wind resistance. So in terms of the real benefits that you get as a user, the first benefit is obviously the efficiency. So if you're a multi-rotor user, or if you're not using a drone perhaps, and using traditional methods, Marlyn's able to survey up to 10 times faster than a multi-rotor and up to 30 times faster than traditional methods. Also, you're able to get survey grade accuracy. So Marlyn carries the 42 megapixel Sony RX1 camera, and it's integrated with PPK, which allows you to get centimeter level accuracies on your surveys. And 42 megapixel is kind of the Rolls Royce of surveying cameras. At the moment, the Sony RX1. There are higher and lower megapixel cameras out there on the market, but 42 megapixels is somewhat of the sweet spot between motion blur and data quality, when you get to higher levels of megapixel count, especially if you're flying lower, because there's such a saturation of pixels within the image, you can get some motion blur, especially at the speeds that a fixed wing drone can get up to, about 15 to 17 meters per second. Thirdly, what Marlyn allows you to do is to survey from anywhere. So Marlyn, with Marlyn, everything fits into the backpack. So the drone, the batteries, all your accessories, all your survey things go into the one package. And that allows you to essentially go anywhere. And also because it's VTOL, you can take off and land in any 2x2 meter location, which we'll be seeing a little bit later in the demo, which allows you to really have complete freedom when you're going out and surveying. And then the final benefit that you get with Marlyn is you're really covered for all sorts of emergencies. So firstly, our software, which is called Navigator, has a lot of different safety mechanisms like geofences and automatic return to homes on low batteries and other things like that. But the most important feature, which again we'll be showing you soon, is the ability to take over in manual flight at any time during the survey. So if you have helicopters come into your area, or you have some inclement weather, which means you immediately need to take control, you are able to do that at any time in both helicopter and airplane mode, and at any wind speed. So even if you're in airplane mode at 55 kilometers per hour, which is the upper limit, then you're still able to take control and either bring the drone home in a safe manner, or execute the internationally recognized turn to the right, which will enable you to get out of any sticky situations. Now, in terms of examples that we have where Marlyn has used these benefits in the field, we've got two data sets here, which I'm just going to quickly go over. But also we will be sharing these with you in an email. I believe it's actually already in your inbox, and all of the links that we share today will be in there. So what I'm going to do is go over them briefly. And then after this webinar, what you can do is to have a look for yourself, download the data sets, and really get a feel for the quality of Marlyn's data. So the first survey here that I'm going to talk about was in the marshes. So this is a pretty inhospitable place. There's not really many takeoff and landing spots. There was a large area, 307 hectares to survey in only 2.5 hours, because they had to do the survey at low tide, which means you only had a very small window in which to survey. And Marlyn was able to do that. They essentially walked out there with the backpacks, set it up, took off for a very small location, and then the eventual survey was able to render data which was able to identify 1.5 centimeter deep trenches and a slope along the marshland that only had a difference of 0.8 centimeters. So that's a really cool data set if you want to go and have a look. The second use case here is to do with the wind. We've actually covered this in a previous webinar, but it's such a good data set, I really want to share it with you. This is a normal survey flight that we took off and landed in 50 km/h winds. And Marlyn was able to survey the 21 hectares of that area without any issues. And the accuracy which we were able to get with that data was within 3 centimeters in both the horizontal and the vertical. So that really shows how even at those high wind speeds, you can still accomplish your normal surveys as a surveyor. So like I said, after this webinar, I highly recommend to go and have a look in your inbox and go through the data sets that we've sent you in there. So what I'm going to do now is I am going to jump into our live demo, and you should be able to see this coming up now. Okay, so here we are out in the field, and if you can't see me, if you can just see, say, a tiny screen at the top of your Zoom screen, you can just pin my view to the center of your screen, but it should be showing up full screen for you now. So you can see we're in an area of swampland with only a very small takeoff and landing area. And what you can see happening is I've just walked in with everything that I need to survey. It's all contained within that handy backpack there. And so what you can see is we're taking Marlyn out of the backpack. Marlyn actually collapses down into 3 separate parts. The first part you can see there that I've got out is what we call the mid part. And then the other two parts are simply the two wings. Now, attaching these two wings is very easy. You just need to slide in a wing leg, as you can see there, and then also slide in two carbon rods. And these carbon rods are used to attach the wing to the mid part. And attaching the wing is very simple. You simply slide the carbon rods into the mid part, like so. And then when they connect, there are white wing clips that you can see there, and they hold the wing securely in place when the drone is in flight. And now we do the same with the second wing. So again, you put the wing foot on, take the carbon rods, and everything that you need for the assembly is just in that insert in the backpack, which is really handy. Slide in the carbon rods. And again, we're going to be attaching the wing onto the mid part. And then as soon as that's done, Marlyn is assembled and essentially she's ready for flight. What you then go and do next is you're going to set up your ground station. And so all that's needed for the ground station is to set up your laptop and to set up the radio antenna. And so the great thing about the backpack as well is firstly, you can take everything that you need for the survey into the field. And then it also functions as this handy table when you're out there in the field. Anyone that's been using multi-rotors that have these tiny flight cases will probably know the pain of kneeling down in the mud for various surveys when they're out there in the field. But with Marlyn, it's really easy. You have this backpack, which is kind of at a nice ergonomic height. So you can see I'm just getting out the laptop now. So Marlyn's software, which is called Navigator, simply runs on a Windows platform. So if you have an existing Windows tablet or laptop, which you're using for QGIS or perhaps your software for your base stations or total stations or anything like that, Marlyn will work on that very same tablet. So you don't have to take another tablet or laptop or anything into the field if, say, it's running on Android or Apple softwares. Now I'm setting up the radio. So what you can see here is I'm actually setting it up at the top of a survey pole. So by no means is this required. I've done it on this video for two reasons. Firstly, because it's cool to show you how you can carry your survey poles in the backpack. And secondly, because we like to do it when we go out and survey because it increases the line of sight of the radio. So our radio at optimum range can get to a range of 7 kilometers from the ground station. And the way to make sure that you massively optimize the range of the radio is to ensure that it has good line of sight to the drone at any time. But when you're surveying, you can also just put it on top of the backpack as well. There's no issues there. But once that's attached, all you need to do is to insert the radio to your ground station. It just goes through a USB connection, and then you're ready to get going in the field. So what I'm going to do here, so I've set up the drone, set up the radio and the ground station, and the next thing you need to do before flight is to go through a pre-flight checklist. So within our Navigator software, you can plan the flight. And then you can also do in that same software, the checklist that's pre-flight as well. So I'm not going to go through flight planning specifically on this video. What I'll be doing after this is sharing with you a link in which you can download the software for yourself and have a bit of a play around with the flight planning on our software. It's super intuitive, so you will get the hang of it quite quickly. So what I'm doing here is going through the checklist. So I've just checked that the radio, the buttons on the RC are in the correct position. Now I'm taking off the pitot tube cover and the lens cap, which are two things to ensure that you have. And it's all done through the checklist. So you don't need to remember it before each single flight. It's all right there, and it's all super intuitive to make sure that everything gets done for both a safe and successful survey. So I'm just checking the propellers on the drone right there, just checking that there's no cracks or anything that are going to cause trouble during the flights. And then next thing I'm going to insert the batteries. Now, the great thing about our batteries is that they have indicator lights, which I'm just checking now. So if you push the button on the batteries, what you'll get is a certain number of LEDs which will light up on the battery. That'll show you how much charge it has. And that's just good to check before you go in and put them in the drone. So you'll see that again here. So full LEDs mean it's a fully charged battery, and I can just slide that into the drone there. You'll see when I put the batteries in, the lights, which are smart navigation lights, will light up just to show that the drone is now powered on. And then you can put the second battery in and attach the cover and continue with the checklist. So here there's just some self-checks that the drone's checking the radio link and the RC link and the GPS connection just to make sure it's all right. Now we're selecting the camera that's in the drone, in which case is the Sony RX1, checking that the lens cap's off and the cover is on. Now I'm going to take the drone and to put it in its takeoff position. So with this, we're just checking that the camera is pointed into the wind and that there's no obstructions in the immediate area of around Marlyn. So what you can see here is a good illustration of just how small an area you can take off with the drone. So with, say, a fixed wing drone, you certainly wouldn't be able to find that area in this vicinity that you could do that takeoff. What you just saw there in that screenshot was the heading check. We're just checking that Marlyn's compass internally aligns with what's there in real life. And then what we're doing here is uploading the flight plan that we previously made to the drone. So all of Marlyn's flight is completely automatic. And it's at this stage where all of the information that the autopilot needs in order to fly the survey is uploaded to the autopilot via the radio connection. So from this point onwards, Marlyn is able to accomplish her automatic flight. You'll see those gray lines come up on the screen, which indicate the 3 flight lines which we've made. So now I'm going to activate the power to Marlyn's motors, and you'll see that Marlyn's smart anti-collision lights have turned on. Now, when these are on, it means that Marlyn is not safe to approach. So that's what we mean when we say smart anti-collision lights. So whenever these are flashing, it means that the drone is powered on and the drone's not safe to approach. You'll also see that the rotating wingtips are moving through their full range of motion. And this is just to test that they're working correctly, and also that that they're able to control the drone when it's in flight. And this is a completely automatic check, so you just need to, as the user, sit back and make sure that it's going through its full range of motion. And so once that's done, what I'll do is then just go around to the other side of my backpack, and then I will set the drone to take off. Whoopa. So Marlyn's taken off. It's going to climb in helicopter mode with all 4 rotors active till it gets to an altitude of 50 meters. And what you'll see is that Marlyn's going to transition her entire body into airplane mode. And when it does so, as you can see here, the central 2 motors are going to actually switch off. So just the 2 motors on the edge of the wings are powering Marlyn now because it's in a nice, efficient phase of flight, and the wings are able to keep Marlyn in the air and hold her weight. So it's at this point, Marlyn's going to climb from what we call her transition altitude up to the mapping altitude, which is in this case 80 meters. So she's going to fly off to her first mapping line, at which time she'll do a turn and then come back and accomplish the first mapping line. So because it's a fixed wing drone, it is going to get a little bit far away, so we won't be able to see much for a second. But what I'm going to just do is just to answer a few FAQs that we typically get in demonstrations of Marlyn. So firstly, with regards to the flight lines, people often ask if it's possible to account for terrain. So here we are in the nice flat Netherlands. We don't get a lot of that. But the good thing is for you guys who are operating in hilly areas is that you can upload DSM or DEM into our navigator software. And then what you can do is to plan your flight plan in steps on top of that terrain. So that way you can make sure that you have a constant GSD across your model, and also that Marlyn's not going to have any unfortunate collisions with the ground if you're able to do that flight planning. The other question that we get a lot is about the payloads. So what payloads can we put in, and is it possible to swap in the field? It's absolutely possible to swap Marlyn's payloads in the field. We carry 2 different RGB cameras, so the 42 megapixel RX1 and also the 20.4 megapixel Sony A7C, plus 2 multispectral payloads, which is the MicroSense Altum and the MicroSense Red Edge MX. We're also looking at the new MicroSense payloads as well. So as Marlyn comes back, you can see that she's on a normal mapping line right here, holding just a very straight, steady flight plan. But what I'm going to do in just a second is to go into Marlyn's emergency flight mode. So we've just had a helicopter come in, so I've pressed the manual button on the RC. And Marlyn is now completely controllable by me with the RC. So I've immediately just turned the right stick to the right, and Marlyn has executed the right turn. Now, the great thing about this manual control is that it's super easy to use. So essentially all that you need to input as a user is one of two movements on the stick. You can either move the left stick up or down, which will move Marlyn's altitude up or move it down. Or you can move the right stick left or right, which will simply put Marlyn on a very gentle turn to the left or a very gentle turn to the right. Now, you don't need to be a pilot to be able to accomplish this. If you say move the stick to the right, Marlyn's going to hold her altitude. So you don't need to worry that the drone's going to crash or anything like that. The drone is very stable and it's designed to be very gentle when you're in this manual control mode. If you were to go completely hands-off from the RC, then Marlyn's just going to simply hold her current altitude and heading, and there's no issues there. You can also transition the drone as well. So you can see that that's what I've done just there. So there's a button on the RC in which you can push, and that if you're in manual mode, Marlyn will immediately transition into helicopter mode. This can be in any orientation, whether it be into the wind or away from the wind or side on or anything. It's quite robust. And so that means you've got the other option. If you are in an emergency situation, you can always take the RC, immediately transition Marlyn, and hold it in her current position. You can move it up or down, and you have full control over the drone at that time. Then you can just move it back into airplane mode afterwards and continue with your survey mission. So you can actually go back into automatic flight after this as well. So it's a really, really great tool to have when you're flying with Marlyn out in the field. At any time, you can just go in and out of manual control. But 90% of flights, you'll just be doing the standard automatic flight. So we're following the standard automatic flight of Marlyn at this stage. So you can see she's coming back to land, and she's flying straight back to above the home position. And then she's going to transition right now back into helicopter mode. So during a normal survey flight, this whole thing would be completely automatic. So she would have taken off, transitioned, turned and done her survey flight, then come back over the home point, transitioned, and then she's going to automatically descend to an altitude of 20 meters. So what happens at 20 meters? Marlyn's just going to sit there and holding her current position. Then it's time for the user to take control. And at that point, the user does a very, very simple controlled landing. So similar to DJI, if you've ever used a multi-rotor or something like that. It's very, very straightforward and easy to use. So then as soon as you hit the ground with Marlyn, you just turn the motors off with the RC, and that will be handled there. So you can see we're at the point now where Marlyn's at 20 meters. She's sat there waiting for the input from the user. We're just going to press the manual button and take control, and I have full control of the drone now. But the drone's going to self-correct. As you can see, it's holding a real stable position. So if there's any wind gusts or any change in the wind direction, she's just going to hold her GPS position on the ground. So that's really easy. So what you can do with such a stable landing is you can really easily land on such a small space, like you can see we had. It's a pretty risky spot. You don't want to land in the water or in the grass, but you can see with Marlyn, it's so stable in helicopter mode that you're able to land even on those small landing areas really, really easily. Now at this point, I'm going to take the batteries out. And for a user in the field, they have two options now. They can either pack the drone up and go home, or you can replace the batteries. There's an option within Navigator if you have flight lines which you perhaps haven't accomplished during the first part of the survey. You can just continue from the previous mission and or from the previous flight line, I should say, and then make your way back to the survey area. So that was a Marlyn flight that we've recorded before. What I'll do is I'll just pop back to our screen. get the right screen up. There we go. Now, what I wanted to talk to you briefly about was our reseller network. So what I saw from our registration list is that we've got people on this webinar from all over the world. So we have Marlyn resellers in all four corners of the globe as well. And so what you can do is head to our website as well. And we have a full list of all of our reselling partners. And that will also be in the email that you'll already have from us in your inbox, if you like. Now, there is also, you'll notice some blank spots on this map. Now, we are currently on the hunt for new Marlyn resellers. So if you see a spot near you, which happens to be blank, and you have a reseller that you'd like to nominate, or if you're a reseller yourself and you're keen to get involved, then by all means, get in touch with us. Again, it'll be on a link on the email that you have in your inbox, and we'll be happy to talk to you about a partnership. Now, also, if you're looking for more information about Marlyn, what you can firstly do is head to atmosuav.com/downloads. Again, it's a link that's going to be on the email in your inbox, and you can download our flight planning software. You can download our geotagging software and have a bit of a play around with that to get a feel for how easy and intuitive the software is to use. If you want to take a really deep dive into how to fly Marlyn, as well as some good articles on, say, how to fly in the wind, you can head to our knowledge base, which is, you guessed it, it's going to be a link on the email in your inbox, and you can have a look through that. Or if you wanted to do an online tutorial on how to fly Marlyn, again, there'll be a link in your inbox, which will be for our online training on the third-party site Udemy. And you can run through the full Marlyn training that a user of Marlyn will get if you really want to see what the drone is made of. So just to round up, what I want to do is just to cover some of the benefits which Marlyn had that we showed you in the demo, and then also before that as well through Marlyn's features. So the first thing you need to remember about Marlyn is she can fly in winds of up to 45 kilometers an hour. So for you guys as surveyors, what that means is that you can take off and land and survey up to 30% a month more, depending on your location, wherever you are in the world. So when you're talking about drones like a fixed wing, like a VTOL, return on investment is a huge part of that decision. So when you can fly up to 30% more than other drones, then that's certainly an important thing to factor in to your ROI calculations. Secondly, with Marlyn, you can take off anywhere, like that tiny little spot you saw us in the video, taking off from in the swamp. So with Marlyn, you can take her anywhere with the backpack and then take off from any tiny spot that you happen to find. Thirdly, with Marlyn, you can get accuracies at the centimeter level with the 42 megapixel RX1 and PPK. You're able to get great survey grade data no matter what your survey challenges are. And then finally, you have all those safety options at your disposal. Firstly, plenty of options within our Navigator software, which I urge you to go and download and have a look at. And then also that manual control option at any time during the flight, you can easily and very safely take control. So that's all I had for you guys today. So what I'll do quickly is I'll just dive into some questions. For those of you who aren't hanging around for the Q&A, thanks a lot for listening. But let's just quickly dive in. So Grzegorz from Poland asked if the platform can glide. So if you are in a situation where, say, you've lost the power to the motors, it's not possible to glide with the drone. You will have some semblance of manual control if there is still power, but indeed the control over the motors is a requirement for keeping the drone in the air as well. Ajit from the USA asks, do the flight plans need any ground control points? I.e., can you do a flight plan purely on distance and latitude and longitude? So essentially what you can do is if you do have essentially a KML, which can be any spot on the globe, that's just a set of latitudes and longitudes, you can drag and drop that straight into the software. and then essentially the drone's able to build its flight plan on top of that. So you don't especially need a fixed point that it happens to have to fly over. You can upload a set of points, a set of latitudes and longitudes as a KML, and then make the flight plan out of that. And then you just need to set your home point for where you happen to be in the field. Julian asks, are the MicroSense payloads integrated with PPK? Yes. So we used to be the only VTOL drone that had that, but I think it's now all the VTOL drones. But yes, all our MicroSense payloads are integrated with the Altum and with the Red Edge. So if you go and do a survey with the multispectral payloads, you absolutely have the PPK option with you as well. Julian also asked, which is a really good question. If you're flying manual and you lose connection, what will happen? So that's a great question, actually, because like I said, the manual control mode's been designed to be very safe to use. So essentially the drone is capable of flying completely automatically, but say you're in airplane mode, you're in manual control, and the RC explodes for whatever reason. The drone will just keep flying its current course and heading and altitude. So it's not going to drop out. It's not going to fly off. And then eventually it's going to hit a geofence, at which point it will trigger the automatic return to home. And then the drone will switch back into automatic mode by itself, come back to a nice, calmly executed landing, and then you have nothing to worry about. Of course, if it gets to also the low battery warning, which you set, might be 20% or 30%, it will also trigger as a takeover of the drone and do an automatic return to home. So you're really covered with a number of different options there. Jamal Crick asks if you can also take off in manual mode. You absolutely can. So indeed, you are able to accomplish any form of the flight in manual mode. So if you wanted to do the entire flight, so take off, transition, and do the airplane mode flight in manual mode, you absolutely could. The drone is still taking photos during that manual airplane mode flight, and so it is possible to do every part of that survey in the manual mode. Sean Boyce asks where you can get info on PPK processing and base station interoperability. I can actually answer that for you because essentially with our PPK unit, we are able to be compatible with any base station. So it's most easily compatible with those that are outputting in RhinoX2 and RhinoX3, but it's also possible to convert the outputs from other base stations from, say, Trimble or MLID that don't do RhinoX outputs. So essentially, whatever base station you have, you'll have the full compatibility with our PPK unit. And I think there are quite a few questions on top of that as well. But what I'll do is I'll get to all of you on a personal message because there is a lot of questions there, which is really, really great. But firstly, thank you very much for joining. Thank you very much for wanting to find out about Marlyn. And secondly, from all of us at Atmos UAV here in Holland, wish you a very happy holidays and a happy new year, and look forward to speaking with you in the new year. If you want to get in touch with us, so again, in that email, which my colleagues have sent through, there's the contact details for us. We have some great deals for people buying before the end of the year. There's still a few days left. So feel free to get in touch if you want to take a part of that as well. Thanks a lot, guys.